Good afternoon, everybody. Now let us start. Today, I will tell you what is the Cauchy's integration formula for highest order derivatives. Now we will study Cauchy's integration formula for highest order derivatives. For highest order derivatives. Okay. So before going to that, I will tell you what we did in my last class. What is the Cauchy's integration formula? Okay. So what is Cauchy's integration formula? First I am writing Cauchy's integration formula. Cauchy's integration formula. So what is Cauchy's integration formula? So we already know it in my last class that f of z be a function, that f of z be a function which is analytic, inside, and on a simple closed curve C. Inside and on a simple closed curve C, and that Z not be any interior point of C. Any interior point of C. Then what is your Cauchy's integration formula? This is your f of z naught is equal to 1 by 2 pi I integration over C f of z divided by z minus z naught dz. That is your Cauchy's integration formula. So what I will do for Cauchy's integration formula for higher order derivatives, just I am changing this Cauchy's integration formula, like suppose in place of f of z I will write f of j. Okay, so I'm changing the color. So in place of f of z I will write let the f function f be a function of j. Instead of z, let it be a function of j. And what is the point I am saying? Z naught is an interior point of C. Now I will replace this one by Z. Let Z be an interior point. I am replacing Z by J and replacing Z naught by Z. That means I am saying Z is an interior point. Z is an interior point of C. So if I will replace f of z by f of j and z naught by z, then what I will write? That means f of j be a function which is analytic inside and on a simple closed curve C, and z be any interior point of C. Then you can write here f of z is equal to 1 by 2 pi I integration over C f of j divided by j minus z dj. So this is the Cauchy's integration formula. Okay, this is your Cauchy's integration formula. Just I am changing f of z by f of j and z naught by z. So this is your Cauchy's integration formula. So what will be Cauchy's integration formula for higher order derivative? So if I will take the derivative, means my statement is same. If f of j or f is a function which is analytic inside and on a simple closed curve C, and z is any point interior of C, then I will write my f dash z. This will be 1 by 2 pi I integration over C f of j divided by this is j minus z square dz. Okay. This is a Cauchy's integration formula for higher order derivative. Okay. Higher order derivative. This is for first derivative f dash z. Similarly, in general, I can write this one as like if I will take the nth derivative, this will be n factorial divided by 2 pi I integration over c f of j divided by j minus j to the power n plus 1 dj. Okay. This is the statement for nth order derivative. For nth order derivative. Okay. So now I will prove it. So now I will write the statement of the theorem and I will prove it. Okay. So this is the statement for Cauchy's integral formula. Cauchy's integral formula for higher order derivative. For higher order derivatives. Okay. So what is the statement? Let f be analytic. Let f be. This is the statement. Let f be analytic inside and on a simple closed curve. Inside and on a simple closed curve C. Let Z be an interior point of C. Z be an interior point of C. Then f dash z is equal to 1 by 2 pi I integration over C. This is f of j divided by j minus z square dj. Okay. I have to prove this thing. Now come to its proof. So what I got from our Cauchy's integration formula? By Cauchy's integration formula. By Cauchy's integration formula, we have. So what we can get from Cauchy's integration formula? That is f of z is equal to 1 by 2 pi I integration over C f of j divided by j minus z dj. This thing we know from our Cauchy's integration formula. So now I will consider when we have to show that f dash z is this thing. So here f dash z means, suppose if I will consider there is f of z plus s minus f of z divided by h, then what will be this one? This will be 1 by h, and f of z is this one. Similarly, in place of z, you can replace z plus h to get f of z plus h. So f of z plus h will be 1 by h whole into this one 1 by 2 pi I. This is 2 pi I. Then what will be my f of z plus h minus f of z? This will be integration over c f of j divided by j minus, in place of z I will write z plus h, so minus z minus h minus, then what will be f of z? F of z will be f of j divided by j minus z whole dj. Okay. So again I can write this one. After this subtraction, what I will write? This will be 1 by h 2 pi I integration over c. My LCM will be j minus z minus h, and this is j minus z. And if I will take f of j as common, then what will be the subtraction? Then after subtraction, only h will left. Okay, this will be j minus j plus z plus h. So only h will left of dj. Okay, you can take this h out of this integration and then cancel with this h. Okay, so then what will be my next step? This will be 1 by 2 pi I integration over c f of j divided by This will be chi minus z minus h whole into this is chi minus z of dj. Okay. So let this be your equation 1. This is your f of z plus h minus f of z divided by h is equal to this one. Let this is your equation 1. Now go to next page. Now consider integration over c. This is f of chi divided by chi minus z minus h, chi minus z minus h whole into chi minus z dj minus integration over c f of chi divided by chi minus z whole square dj. Okay. So if I consider this as subtraction, what will be this one? Taking integration over c common, then what will be this one? This will be f of chi divided by chi minus z minus h, chi minus z minus f of chi divided by chi minus z whole square of dj. Okay. So if I write again simplifying it, what we will get after this subtraction? If I take common here, f of chi divided by chi minus z, then what we will get? This will be 1 divided by chi minus z minus h minus 1 by chi minus z dj. Then after again simplify it, this will be integration over c. This will be f of chi divided by chi minus z into, then what will be the subtraction of this one? Again this will be h divided by chi minus z minus h whole into chi minus z of dj. So I can do this one as this is h integration over c f of chi divided by this is chi minus z minus h chi minus z whole square dj. Okay, so this is my this one. So if I will multiply 1 by 2 pi I, then what will be this one? So when this one is this one, so if I will multiply 1 by 2 pi I, because in equation 1 this is same. In equation 1 it will say this is 1 by 2 pi I into this one. We record this one. So to get that one, I have to multiply 1 by 2 pi I. So 1 by 2 pi I whole into this one. So what is this one? 1 by 2 pi I whole into f of chi divided by chi minus z minus h whole into chi minus z dj minus 1 by 2 pi I, and I am multiplying this one. Integration over c f of chi divided by chi minus z whole square dj is equal to h by, here this is the right hand side, so here also I will multiply this 1 by 2 pi I. So s is there before, so s by 2 pi I integration over c f of chi divided by chi minus z minus h whole into chi minus z whole square dj. Okay, so this thing you will get. So from equation, and this is your f of z plus h minus f of z divided by h. Okay, from equation 1 you can add this is from equation 1 I already told you, and then just by equation 1 I am replacing this one by this formula. Then this is 2 pi I integration over c f of j divided by j minus z whole square dj is equal to s by 2 pi I. This is s by 2 pi I integration over c f of j divided by j minus z minus h whole into j minus z whole square dj. Okay, so let this will be your equation 2, and our proof, we have to prove that this one is equal to this one. That means our next time is to show that the right hand side of this equation 2 is 0. So if I will show this one as 0, then this one will be equal to, or first term will be equal to second term. So how I will show this right hand side of this equation 2 was 0. Now I will show this thing. This is my right hand side, h divided by 2 pi I. This is 2 pi I. Okay, h divided by 2 pi I integration over c f of j dj divided by j minus z minus h whole into j minus z whole square. Okay, now I will show this thing as 0. So now go to next page. So now let m be, let m denotes the maximum value, of f of j. Let m denotes the maximum value of f of j on C, and let L be the length of C. M is the maximum value of mod f of j on C. C means on this curve. But, and L is the length of C, and D be the shortest distance. D be the shortest distance from Z to any point. Shortest distance from Z to any point on this curve C. Okay, so now I am assuming m is the maximum value of mod f of j on this curve C, L is the length of curve C, and D is the shortest distance from Z to any point on C. Okay, अतः for any point j on C, we have j minus z modulus must be greater than equal to D, because D is the shortest distance from Z to any point on C. Since D is the shortest distance, so if j will be any point on C, then j minus z must be greater than equal to D. And what will be your j minus z minus h? So this thing must be greater than, this is j minus z minus h modulus, j minus z is greater than D, so this thing must be greater than D minus h modulus. Hence I can write mod of f of j divided by j minus z minus h whole into j minus z whole square. This modulus must be less than equal to m divided by, this one is d minus mod h, and this one is d. Okay, we got already this one is greater than d. That means if I reverse this thing, 1 by j minus z modulus, this thing is less than 1 by d. Similarly, this one is greater than d minus h. So if I will reverse this thing, then 1 by j minus s modulus will be less than 1 by d minus s modulus. So I am replacing these things. Okay. So this is d minus f of j's maximum value is m. Here it is written, and 1 by j minus z minus h as maximum value 1 by d minus h. 1 by d minus mod h. Similarly, j minus 1 by j minus z. 1 by j minus z is less than 1 by d, and here square, so you will write here d square. Okay, so I can add this one is less than this one. So from 2 we have, so in the last page there is equation 2, so I will write from that thing. Now from 2 I can write f of z plus s minus f of z divided by h minus 1 by 2 pi I integration over c f of j dj divided by j minus z whole square modulus. So whatever my equation 2, I am taking its modulus. Okay, so here is your equation 2. Okay, so I am taking modulus of this left hand side. This is the whole this thing. I am taking the modulus of the left hand side. Similarly, I will take the modulus of the right hand side. And I have already evaluated what is the maximum value of this thing. Okay. Now I will take its modulus. If I will take its modulus, s by 2 pi I its modulus will be h divided by 2 pi, because i's modulus is 1. So now go to the page. So modulus of left hand side is this one. Then what will be my modulus of right hand side? And this is the modulus of the modulus of right hand side. I can add this is less than equal to, because there is a less than equal to symbol. So less than equal to, that means I am just omitting one step. So this will be h divided by 2 pi. Plus 2 pi i's modulus is 1. Okay, mod of I is 1. That's why I am writing only 2 pi, and then less than equal to symbol. Then I will replace this one by its right hand side, because I am giving the less than equal to symbol here. Okay, so I will write this is mod m divided by d minus h. This is d minus h, d minus mod h into d square. So then what I will write, if I will take limit h goes to 0, so if I will take limit h goes to 0, so my right hand side I will apply limit on both sides. Limit h goes to 0 on both sides, so the right hand side will be 0, because there is h into something. So in place of h, if I will put 0, then the right hand side will be 0. Then what will be my left hand side? The left hand side will be f of z plus h minus f of z divided by h minus 1 by 2 pi I integration over c. This is f of j divided by j minus j square dj. This thing will be 0. Okay, so then what I can write, then this is independent of h. So if I will apply limit h goes to 0, then this will remain unchanged. So I can write limit h goes to 0 of f of z plus h minus f of z divided by h is equal to, I will take this thing to right hand side. This will be 1 by 2 pi I integration over c f of j divided by j minus z square dj, and this is nothing, this is your f dash z. Okay, so I can add my f dash z is equal to this one. So now this is proved. Okay, similarly, by a method of induction, if I will write something, just one line more, this is this one, f dash z is equal to 1 by 2 pi I integration over c f of j divided by j minus z whole square dj. Now if I will go to its next page, by applying induction on n, we get f nth derivative at z will be n factorial divided by 2 pi I integration over c f of j divided by j minus z to the power n plus 1 dj, or you can say this is integration over c. In several problem, we will apply this formula. Integration over c f of j divided by j minus j to the power n plus 1 dj. This will be, I will divide this thing on right hand side, so this will be 2 pi I divided by n factorial f n at j. Okay, so this is the required problem for solving uh, problems. This is the required formula for solving several problems related to this higher order derivatives of Cauchy's integral formula. This is the higher order derivatives, higher order derivative formula, and higher order derivative for Cauchy's integral formula. Cauchy's integral formula. Okay, I will solve one of the problems. Before going to that problem, I will tell you what is Cauchy's inequality. So now comes to another page. I will tell you what is Cauchy's inequality. So what is Cauchy's inequality? First, I will tell its statement. Let f of z be. Let f of z be analytic inside and on a simple closed curve C. Simple closed curve C with center Z0 and radius R0, or you can say radius R. Okay. Let f of z be analytic inside and on a simple closed curve C. C is a circle, its center is Z0 and radius is R. Okay. Let m denotes the maximum value of let m denotes the maximum value of mod f of z on curve C. Then what is the Cauchy's inequality? Then f n z0 modulus is less than equal to n factorial into m divided by r to the power n. Now I will go to its proof. So we have from, or I can say from Cauchy's integral formula, for higher order derivatives. Cauchy's integral formula for higher order derivatives we have. So what we got from Cauchy's integration formula for higher order derivatives? We got fn z0 is equal to n factorial divided by 2 pi I integration over c f of z dz divided by z minus z0 to the power n plus 1. Okay, I am replacing j by z and z by z0. Okay, because here z0 is the point which is lying inside C. Okay, so I am just replacing these things. So this will be my Cauchy's integral formula for higher order derivatives. So if I will take its modulus, what I will get f n z0 modulus is equal to n factorial divided by 2 pi. Here also I am taking the modulus, so I modulus is 1. So this will be n factorial divided by 2 pi I. Then what is my right hand side? Right hand side f is your f of z. Do you know its maximum value? Its maximum value is saying m. Where it is written? M. M denotes the maximum value of mod f of z. So I will make a less than equal to symbol here. Then I will put the maximum value here. M divided by and Z0 is the center and R is the radius. This C is the circle whose center is Z0 and radius is R. So Z0 is center and radius is R. So Z and C is Z is any point on this C. So Z minus Z0 must be R. So this will be R to the power n plus 1. So this will be m divided by R to the power n plus 1. This will be, we know already one formula, integration over C f of z dz is less than ml. I already told you this formula where m is the maximum value of mod f of z, whose integration you have to calculate. And what is L? L is the length of curve C. And for this given equation, this integration of f of z divided by z minus z naught dz. And what is the maximum value of this one? F of z has maximum value m and z minus z naught is your r. It is given z minus z naught to the power n plus 1. Z minus z naught because C is a circle whose center is z naught and radius is r. And z is a point on r. Sorry, z is a point on C. So z minus z naught is r and z minus z naught to the power n plus 1 means this is r to the power n plus 1. So the maximum value of this integral is this one. Then this is the maximum value, this m value. Then what is and what is its n value? What is the length of this curve? This curve is nothing but a circle whose center is z naught and radius is r. So since its radius is r, so what will be its length? Its length will be 2 pi r, just its perimeter. So I will write this one 2 pi r. Okay, so after cancelling this r, what I will get? This will be n factorial divided by 2 pi also cancel out and 1 r will cancel out. So what will left? So this is 2 pi n factorial divided by r to the power n into m. So this much will left. Hence we have to prove that one. Okay, so hence we got f n z naught modulus is less than equal to n factorial m divided by r to the power n. This is your Cauchy's inequality. Okay, so now comes to the next page. So next page is saying about Liouville's theorem. This is another theorem, Liouville's. This is Liouville's theorem. Now comes to its statement. A bounded interior function in a complex plane is a constant. A bounded interior function in a complex plane is constant. In a complex plane is constant. Okay. Suppose a bounded interior function in a complex plane is constant. So now comes to let f of z be a bounded interior function. Be a bounded interior function in a complex plane. Okay, in a complex plane it is given that f of z is bounded and this bounded and interior function. What do you mean by interior function? Interior function means it is analytic everywhere. What do you mean by interior function? Interior function means it is analytic everywhere in C. Everywhere in C. C means in complex plane, whole complex plane. Okay. So it is saying that it is bounded. So I can write since f of z is bounded, so there exists a real number. So there exists a real number m such that f of z modulus is less than equal to m for all z belongs to complex number. Okay, let z not be any complex number. Let z not be any complex number. Okay, let z not be any complex number and r greater than 0 be any real number. Let z not be any complex number and r greater than 0 be any real number. Then by process inequality we have, so what we read our process inequality, we read that f dash, we read for n. Now if I will replace n by 1, that is my first derivative, so f dash z naught, this thing must be less than equal to m divided by r. See what we read in the process inequality, f n z naught, modulus of f n z naught is this one, and f n means this is the nth derivative of f of z naught. So if I will replace n by 1, so the first derivative of f dash z naught is less than equal to, in place of n I am replacing 1. Okay, so this will be m divided by r. So this thing what I have writing, so f dash z naught modulus is less than m by r. Okay, now taking r as infinity, since I am applying this thing for whole complex whole set of complex number. So if I will take this limit r goes to infinity, we get f dash z naught tends to 0. So if r will goes to infinity, then m by infinity this will be 0. Since z naught is arbitrary, since z naught belongs to C, C means the set of complex number. Since z naught belongs to C, be arbitrary. Since this thing is arbitrary, so f dash z naught is equal to 0, or you can say since z naught is arbitrary, so we can write f of z, we can write this f dash z is equal to 0 for all z belongs to C. Okay, since z naught is arbitrary, so I can use a arbitrary number z also for all z belongs to C. So now we got this thing, f dash z is equal to 0 where z is belongs to C any arbitrary number. Since f dash z is equal to 0 for any z or for arbitrary z, so we can say here f of z is a constant. F z is a constant function. Okay. So now I will do a problem. We know our process integration formula for higher order derivative is this one. So if I do a problem, suppose it is saying find integration over C e to the power z divided by z to the power n dz, and this one will be 2 pi I divided by n minus 1 factorial, where C is the circle, mod z equal to 1. Okay, C is the circle and the curve C is given by, it is a circle and its equation is mod z equal to 1. So mod z equal to 1 means z minus mod of z minus 0 equal to 1. That means its center is origin and radius is 1. Okay, this is my curve C, and what it is saying, find integration of this one, this will be this one you have to solve. So here I can say, here f of z, this is your e to the power z, this is analytic, in curve C. Okay, because exponential function is analytic everywhere. So e to the power z is analytic in C, and whatever your z naught is, it is given z to the power n. That means z minus 0 to the power n. So I can write your z naught is 0, and z, f of z is this one, and z naught is 0, which is lying inside C, or which is lying in the interior of C. Say this is your curve C, or this is the circle C, and 0 means the origin, and it is lying inside C. Okay, since z naught, which is equal to 0, which is lying inside C, thus, okay, thus by Cauchy's integral formula for higher order derivatives, Cauchy's integral formula for higher order derivatives, for higher order derivatives, we have, so what we have, integration over C f of z divided by z minus z naught to the power n dz will be 2 pi I by, here this is the formula. So in n plus 1, if I will write n, then here also I will write, in place of n factorial I will write n minus 1 factorial, and here also I will write f n plus 1, f n plus 1 derivative, and here the point is z, and here the point is z naught. So I will write this is 2 pi I divided by n minus 1 factorial f n minus 1 factorial, sorry, f n minus 1 the derivative at z naught. So what will be this one? This is 2 pi I n minus 1 factorial. So what is the, here here f of z is e to the power z. So here f of z is e to the power z. So if you will take its derivative, it will be again e to the power z. Similarly, if you will take the second derivative, it will be again e to the power z. Similarly, if you will take its n minus 1th derivative, again it will be e to the power z. F of n minus 1, that is the n minus 1th derivative. This will be again e to the power j. Okay, so this is e to the power, in place of z I will put z naught. This is e to the power z naught. So this will be 2 pi I by n minus 1 factorial, and z naught is 0. So this will be e to the power 0, which is 0 1. So this will be 2 pi I by n minus 1 factorial, e to the power 0 is 0 1. So only this much. So this is 2 pi I by n minus 1 factorial. Okay. Similarly, I will do just one more problem. Suppose go to next page. So suppose there is another problem. Evaluate integration over C sin z divided by z minus pi by 2 whole square dz, where C is the circle, mod z equal to 2. We have to find its solution. So what is mod z equal to 2? That means this is z minus 0 is equal to 2. That means this is a circle whose center is 0 and radius is 2. So first I will draw it. So this is 1 2 1 2 1 2 1 2. This is the center origin. So my curve is this circle. Okay, so I can write here f of z is sin z which is analytic inside and on C. Okay, and what is my Z naught? Here Z naught is pi by 2. If you see pi value is 3.141, so pi by 2 means its value is 1.57, something like this. Okay, so 1.57 means it must be less than 2. Okay, so it will lie, suppose this is your 1, this is your 2, so 1.5 will lie here. So that means you can say your pi by 2, this is your Z naught, is lying inside C. This thing is lying inside C, on this curve C or on this circle C. So now by applying Cauchy's integration formula, Cauchy's integral formula for higher order derivatives, So what is that formula? And this is square is here. So okay, first I'll write the formula: integration over C f of z divided by z minus z naught to the power n plus 1 dz is equal to 2 pi I by n factorial fn at z naught. And here z minus z naught to the power 2 is here. So if I write n equal to 1, so integration over C f of z divided by z minus z naught to the power 2 will be of dz is equal to 2 pi I by 1 factorial, then f dash z naught. So this is the formula. So if I use it here, integration over C of sin z divided by z minus pi by 2 square dz. So in place of f of z I am writing sin z. So this will be my 2 pi I, and your 1 factorial is 1. And what is f dash at z naught? Your f of z is sin z. Okay, so your f dash z will be cos z. And what is f dash z naught? Z naught is your pi by 2. So your f dash pi by 2 will be cos pi by 2, and cos 0 is 1, so cos 90, this is 0, so this thing into 0, so this will be 0. Okay, this is your answer. So similarly you can do so many problems. So today is this much. Thank you.